Before we get started, I'm going to ask you to get out those iPhones, iPads, Androids. We're going to work on both devices. We're going to work on our Chromebooks or computers that we have here. And we're also going to work on our computers that you're on right now with this conference. And we're going to work on our phones right alongside of us here. In fact, right here, I have an Android simulator here. And I also have my iPad, which I'll project on so we can reach both iOS and Android people. Okay. So here's what I want to show you here. All right, I'm going to give you the link here, and if you could bookmark this for something later in case you need it, there's some valuable links here. But let me just get the link for you here, and I'll drop it in the chat, so you can open it up if you want. But right here, oops, sorry, wrong thing. But let me just share that link with everybody here. Okay, if you go there, and I'll project. You don't have to go there. I'll project, but if you click it and just save it on a new tab and look at it later, so you don't lose it. But I'll actually show my screen so make it easier for you. Okay, so if you are, let me just present here. If you are an Apple iOS person, hold your camera to this icon right here, this first one there, and then go to the app on App Store and please download that app. If you have an iPhone or an iPad, you're gonna wanna go here, take a picture of this, and it'll take you right to the link on App Store. If you are an Android user, okay, like the Samsung Galaxy or you name it, right? You're going to need to download 2 apps for this to work. You're going to need to take this one here and this one here. There's 2 apps on Google Play that I'm going to need you, or Play Store, that I'm going to need you to download. This one is a link to GeoGebra 3D Calculator for Android. And this one is a link to an app that Google developed called Google Play Services for AR. In essence, the second app for Android people is what activates augmented reality for several apps, not just GeoGebra, okay? If you have an Apple device that is an iPhone or an iPad, again, iOS, then that iPhone or iPad already comes with AR built within it, okay? So you Apple people don't need a second device, if you will, all right? So again, I'll leave that screen up there for another minute. So for those of you that are coming in, if you could please take a picture of this for iPhone, iPad people, and take a picture of both of, and go to both of these to download to your Android right here is what you will need to do. All right, so go ahead and do that. And I'm not going to start till everybody has those apps. Nobody left behind. And I commend you for having the strength to do another virtual conference here when it's so beautiful outside. All right, cool. And if you're willing to go ahead and give me a thumbs up in the, give me a thumbs up when you have those apps installed on your device, that'd be cool. I see a couple of you already. That's awesome. All right, you got 2, 3. Again, iPhone or iPad, you're gonna download this one here. Take a picture, I'll bring you right there. I love QR codes, they're like the greatest thing. Yeah, cool. All right, Candace, Nicole, Christina, Carol, Laura, and Zobin. How are we? How you doing there? I don't know if I saw a thumbs up yet, because I can only see 6 at a time here. Just want to leave anybody behind here. All right, Christina's good. Awesome. All right, so keep going here. Now I see everybody here. All right, but again, you have the link to there, so I'm gonna go ahead and I don't want to waste time. I want to get started, but you have that link to that Google Slides thing right there. Anyway, let me exit out of full screen mode. And all right, so keep that link handy in another tab. Again, I'll drop it in the chat in case a few of you showed up late, because I think it doesn't go back a little bit. All right, so there it is, the same thing, so you can get it. I think that's the same thing, yeah. Anyway, so now you have it on your device. We're gonna go to it later. I need you to do one more thing. All right, the first task was to get the app on your devices, or the apps for the Android, right? Now the second thing I need you to do is to go to geogebra.org in your browser. Okay, not on your phone, preferably, because I like to build on my computer or Chromebook. A phone or tablet's not the easiest place to build on. But students, you know, we'll build on both. But for us as teachers to plan for effective learning, whatever, we'll build on our Chromebook or on our computer, just like we do. And I always tell teachers, when you work with students remotely or hybridly or whatever, if that's the word, when I share my Zoom screen, it holds your screen hostage. So I tell teachers, press the escape button and then make that Zoom meeting like half of the screen. Because in order for this to work effectively, what you really want to do, just move my eyes here. What you really want your students to do is to actually hit that plus sign, their new tab, and you want to yank that tab out and pull it over. It's so vitally important that in this age of remote learning, when you share your screens, it takes everybody's screen, it takes your screen, holds it hostage. Students have to know by default to hit escape, squish it to cover half their screen, drag, and you need a separate tab to play. If we want to actively engage our students, they need space on their screen to play around while the Google Meet or Zoom is going on. You see what I'm saying? So that's a good habit to get students to get into, and that's the habit I'm going to try to encourage you to do here. We'll build off on the right, or we're going to build on our phones or tablets, but we're going to keep our GeoGebra up in front there. So Zoom on half. Please have Zoom on half of your screen, and have geogebra.org open on the other one here. And if you don't have a GeoGebra account, I'm going to ask you to go ahead and create one. So to create a GeoGebra account is very simple. You just go to where it says sign in up here. I'll show you how to do it fast and not take forever, because there's an easy way and there's a long way. Go to sign in, upper right corner. If you're totally brand new, you want to hit create account. If you are not brand new, go ahead and log in now. You guys know how to log in. But if you're totally a newbie, hit create account. The fastest way to create an account is just do it through Google or one of those platforms there. That way you won't need a password. If you put an email and all this crap down here, it's going to take 2 minutes for it to come and confirm your account. You don't want to deal with that. Just don't memorize a password. Pick one of these and create your brand new GeoGebra account. And the reason why we need this is because we want to save our constructions. We need a place to save it to, so it saves it to your account. GeoGebra does not spam you with junk email. They don't. Even if you say I want to receive occasional newsletters, you might get one a month on what's new. You know, that's it. They don't spam. All right, so we're going to rock and roll here. So let you guys create your accounts, and sorry about that. And we'll do this. So let me go here. Once your account is created, you should see. One second. Once your account is created, you should see in the upper right corner, right? You should see a letter where my mugshot is right there. You'll see a letter there. That's the evidence that your account has been created, and we're on the home page here. All right. So I'll give you another minute or two to sign in, and create your account there, and then we'll have fun. And if you were in the morning session, you probably the morning session there, it was recorded. I got permission that once we download it, I could put up on YouTube, my YouTube page. Just a general introduction to GeoGebra. We have apps and we have resources. Resources are activities that have been made by people all over the world, and you can find them here in their classroom resources there. But we're going to explore one of the apps, and that is the 3D calculator. So once you're signed in, what you want to do is go to where it says 3D calculator right here. That's where we're going to play on our computers right now, and then we're going to play with it in augmented reality on our phones and on our tablets. We're going to create something from scratch right here in 3D on our Chromebook or computer, and we'll be able to open it right on our phone after we save it. And then we'll project it in augmented reality to walk around it and explore it and do all that, right? Now in New York State, I just found out that the Regents was canceled for January. No one's heard about June yet, right? So curriculum, because of COVID-19, right? It's almost like curriculum is going to have to vertically align for everybody, English, social studies, wherever. So, you know, less is more. So instead of trying to cover all the concepts here virtually by lecturing, you know what? Instead of, we can actually take this app and help students richly absorb many of the geometry and many of the algebra concepts that they learn often procedurally, but we can learn it and dig deeper conceptually. And you'll see exactly what I mean in just a minute. So if we go here, once you're logged into GeoGebra, go to 3D calculator right here where it says powerful math apps. And go ahead, and now you could start typing here. You could, but if you hit the circle triangle, I want you to take a minute and just play. Just play with stuff. Like you could plot points, right? Like this. And notice if I plot a point and I could drag it up off the plane, ooh, I'm in 3D, yeah. take a point down, dip it below, okay? We could, again, the basic tools are here. I mean, like, how many of you ever made a circle in like Desmos or in GeoGebra, right? You just click a point and move out. Well, a sphere is kind of the same way, right? You just click on a point and just kind of slide. Ooh, we can make spheres. We can make spheres here, right? Again, this is my favorite app of all time. It is super powerful. And if you're one who's kind of tech anxious, it could be overwhelming at first, I'll be honest. But usually it's the non-tech anxious people that will sign up for a session like this. So I'm assuming that you guys are interested and play with it. But you could just mess around and start doing things. Like, for example, here, you can make a cube, right? Check this out. If I hit the cube tool right here, you know, I just click it and plot a point and plot a point. And it's almost, that's a great question to ask students. It's like, well, why is it that all I need to make a cube is 2 points? There's some deeper conceptual reasoning that's going to be going on there. Okay, well, how come I don't need more for a cube? 2 points determines a cube, you know? Isn't that kind of question we could ask why to students and have them take a few minutes to reason? Well, shoot, since all edges are equal out this 6 square, you know what I mean? That kind of thing. But it gets even better. We can actually go to the net right here. See what I mean? We can hit the net tool. It's up there. And we could just touch the cube. Forms a net. Try it. Again, don't just watch me. And again, please don't be hesitant. Do not, please unmute your mic and speak. I mean, this is a conversation I want to talk with you guys. I can't see most of you, but at least we can talk with each other. This is an ongoing discussion here. If you have questions, please stop. Stop me dead in my tracks here. Now, here's the cool thing. If you actually see that arrow down there, you see, if you look here, the net tool is still turned on because it's bolded. I got to turn that tool off by hitting the move arrow, which is right down here. Anytime you do something that lets you do it, I can move these points around again. I can click H and then bring that thing up, right? But did you know you can fold up nets like that? Pretty cool too. You can actually take any one of those gray dots and you can actually fold it back up. And kids can actually just play with it and see. You as a teacher don't have to tell them the surface area is 6s squared, right? You can actually, if you drag in the white space, you can just move it all around and have the students see, oh my gosh, that's what a net of a cube looks like. It's just 6 squares. Now, not every student needs that, but this will help. This would definitely help a lot of them, I would think, you know? But again, but you could actually see how surfaces cross each other. But again, I wish I could do a whole few hours on this, but the time doesn't allow here because there's so much playfulness you could do. You could reflect about planes. You could do so much, and it's actually not too bad. Go ahead, Stephanie. Do you want to unmute yourself and ask a question?
Yeah. How do you use intersecting two surfaces?
Great question. If you click on it, the clue is down here. Select two surfaces. I'll show you a classic example from like beginner, like first year geometry, with like, you know, the axioms, postulates, and theorems that we always teach kids, right? Isn't there a postulate that says something like by the way, you don't even have to, you can, if you right click in here, you can actually hide the axes and just have something like this, right? A plane contains what? At least 3 non-collinear points, right? So check this out. I'm gonna actually plot 3 points. I'm gonna hit the point tool and I'll just put one on the gray plane, a one over here, and then I'll just click. I'll click and then I'm gonna bump this up a little bit, right? So see how I have two A and B are on the gray plane there, but C is up in the air, right? Now, I'm gonna select the plane through 3 points tool. I'm gonna answer your question. We're gonna use that tool in just a second. So every time you click it, a hint comes up, select 3 points. Okay, 1, 2, 3. And there's that plane through the 3 points there. Again, I need to turn that off. Hit that arrow to turn off the plane, but I can move it around, see it? Now, how do I mean, isn't this something we often teach students? We just kind of direct lecture, okay, kids, if 2 planes cross, hey, look, where does the wall meet the ceiling? And they're kind of like, that edge, the line there. But you know what? Let the students tell you. If you actually have them just intersect the 2 surfaces there, what does it say? So you just click on one, click on the other, and boom, there it is. The students can see for themselves that it's a line, right? Again, I'll do that. I'll repeat that action one more time. Intersect two surfaces. Whoops, let me, I gotta redo there. So again, intersect two surfaces, touch one plane, touch the other plane. Hang on. All right, intersect, touch one, touch the other, and actually just made that line yet again. Okay, but I made a few of those lines there, but there it is. Now, at any time, see if you use your mouse to click on C, you can move it either up or down, or you can use your mouse to move it at the same height above that gray plane. Lo and behold, students discover, wow, if two planes cross, how do they cross? If they intersect at a line. I can explore this here on the computer, or I could also do it in my augmented reality space on my phone. Okay, but I want to actually get into the habit, because the title of the session was something like building, assessing spatial awareness with students. And think about what we do in 6th grade, or 5th or 4th. We teach kids how to plot ordered pairs. Well, X comma Y. Well, those are coordinates, but what exactly is a coordinate? Okay, well, let's role play here. Let's talk teacher to teacher for a second. What is a coordinate? Like, how would you describe the word coordinate without Googling it? Like, what is it? Feel free to unmute anytime. Good refresh.
Coordinates are points?
Not quite. The points are points, but coordinates are not exactly points, though. That's what a lot of teachers say, most students say. But like, if I have the point A and the coordinates are 3, 4, the coordinates are 3, 4, but the point is the point. But what do the 3 and the 4 represent? Like, what are they?
Locations.
Yeah, you got it. Locations. Coordinates are numbers that tell us location. I think, can you think of a game we played as a kid? Like, you know, when you played as a kid, Milton Bradley made? Thank you. Those are A10, right? B4, C3. Well, you know what? So here's my question for all of you. Ready for this? I'm gonna actually, I'm actually gonna take my iPhone here. I'm gonna project it on here. So check this out. Here's a question I have students. Again, talking about in the very beginning stages. We've got to take baby steps here, right? Can you see him? Can you see my phone there coming up? All right. So check this out. Right on my desk right here, I have, what do you call this? What kind of a solid is that?
A rectangular prism?
Very good. Well, instead of showing the pictures to students here, can we actually have our kids build this thing in this calculator? I'm going to bet you to say you can have 4th grade students building this thing. And see, my problem, again, I'm not going to change, curriculum's not going to change overnight. I get that. But with COVID school right now, because I hate saying that, it's like, you know what? You know, the curriculum has all been upside down anyway. So why not take time to actually explore things more conceptually, right? Instead of saying, hey, this is a prism, how could we build this thing in this calculator? That's going to be one of the tasks we accomplish today. I want to just build this. And after I build it, we're going to open it on our phone and we're going to put it in augmented reality and use augmented reality as an effective model. We're going to model test it, see how well it fits on top of this thing. And kids love doing it. It's fun. But first we got to build it. And see, this is where kids, the critical thinking. We live in a 3D world, do we not? So why the heck do we stay married to the coordinate plane from 6th grade, 7th grade, 8th grade, 9th grade? No one ever, even in geometry, we talk about translations and rotations and stuff. Nobody moves. The z-axis doesn't exist, it seems. X and Y are, you know, the 2-dimensional coordinate plane's flat, but there's a z-axis sticking out at you. And if we live in a 3D world, why do we teach mathematics? Why does so many curricula never involve 3D? Kids go to calculus, we wonder why the heck they're struggling so much. It's because the only surface area volume stuff that they talked about is like it's only the only really 3D connections they ever had was like surface area volume, and for that case, it was mostly give them the formulas and plug and chug, right? But here we can actually conceptually build and reason and think. So I'm gonna not make you so dizzy, but what I am gonna do here is take that same picture. If you could reload the page, make sure that Zoom call is about half the screen, all right? And make sure you have an area to play with on the right. I'm gonna take that picture right there. Give me a second. Where'd I have it? I just took that picture. Where'd I put it? There it is. I took a picture beforehand, so I have to keep holding it up. We're gonna build that here, and then we're gonna open our phone and look at it. Now, I know you don't have this block in your house. Now, when if this were gonna be in person, right, I was hoping I would actually bring these with me and you would have these at the table. You know what I mean? And you would actually have stuff to build in front of you. But if you have a play set of blocks, if you have kids at home, You want to run and get one of these? Be my guest. All right. Now, this is what we have right here. So talk to me. I mean, again, the way this looked, the red axis, the x-axis is red, the y-axis is green. In fact, if you kind of look at, this is what we're used to seeing, right? Pretty much from 4th grade on up. But now I want to talk about, the title of the whole thing, Assessing Spatial Awareness and Seeing. Well, instead of X, Y, we live in a real 3D world. Let's actually build this thing. So can anybody help me? Can we actually build this thing? Like, look, again, we don't know much of the tools per se, but what's one of the first things we teach kids about with coordinate geometry? We're in the coordinate plane. What do we often teach them? When we're in the coordinate plane, what's one of the first things we say? We work with them on?
The origin.
We start the origin, but we're talking about plotting points, right? So would it be okay to, and this is a conversation I have with students, would it be okay to put the origin, what are the coordinates of the origin? 0, 0, just type it in, 0, 0, 0, oops, type it in, hit enter, right? It plots a point at the origin right there. Now, if you,
I'm sorry, I have a question.
go right ahead.
So with students, we talk about X and Y. What would the third axis be?
Z.
Oh, Z. Oh, right. Okay.
Yep. In fact, you know what I can do here? If you want to go up here to the settings, and you could save master settings. If I go to settings here, if I go to x-axis, right there, the tab there, I'll just label it X. The y-axis, I'll label Y. Oops. In the z-axis, I'll put a Z there so it's easier for us to see. Right there. You see how X, Y, Z. RGB, red, green, blue, RGB, XYZ. Think of it that way. But if you ever want to label it and go here and go to settings, if you actually go to the settings bar, you can hit save settings. It'll save your settings when you're logged in as you. That way you don't got to do that every time. All right.
Okay, thank you.
You're welcome. Yeah. So all of you are going to help me build this prism in here. So that's the lower left corner, right? What would you say the most important thing to put in here is? I mean, like, I notice I have rectangles, I have rectangular faces, but let's not worry about the polygons right now. Let's just work on, what do you think the most important part of this whole prism is on the right side?
The vertices?
Making it.
Yeah, the vertices. So one vertex is 0, 0, 0. So can you work with me here? If this edge is 9.7, can you give me another vertex I could put? Again, there's no wrong answers here. Kids put these in all different places, right? What's another coordinate I could use?
9.700.
Type it in here. Boom. Right? X, remember, X is left, right, Y is like back and forth, and Z is up and down now, right? You see what I'm saying? So again, and by the way, if you touch on A, if you click A there and click on AA, you could show the value. If you go here, just touch it, AA, show value, right? So we could see these coordinates as we're actually making them. Now, some students may want to hold this thing sideways. So some kids may plot 19.6500. That's not wrong, is it? It's just different. So there's so many, but see, this is where students are synthesizing, students are creating. Try asking Siri, hey Siri, what are the coordinates of a rectangular prism? She probably can answer that. But this is something I totally believe that's in the scope of understanding of 3rd, 4th, and 5th graders. Not just the honors kids, all students. Not all, I mean, some students will struggle with it, don't get me wrong, but it's possible. So what else, what other coordinates here? We have 8 vertices, do we not? Can you give me some more on the floor here? What would some more coordinates be?
0, 4.10.
0, 4.10. Looks good. I'll actually click on that and I'll AA show value. Oh, I like it. What else? I mean, it's almost like gotta be over here, doesn't it?
19.65.
Let's see, 19.65. Man, that's, I'm gonna have to zoom out. That's gonna be way up in Kingdom Come up there. There it is, see? It's like yonder way high. By the way, if you hold down the shift key, press shift and use your mouse, you could actually, if you click your mouse while holding shift, you could actually like drag it up and down like that. So I'm gonna need some more room here, right? So I can actually see it in a way. But I'll just click it and then I'll just show the value there. That's 19.65 up, right above the origin, isn't it? What else? What about this one? What's the next grade? What about the one on the floor? What about the one that's invisible here? What's the one in the corner gonna be? Like lower right.
9.74.10.
Very good. But see, you see how this is an exercise for spatial reasoning with students at that grade? Even for some of us teachers, it's like, wait a minute, you got it's almost like you got to do a double take and look at it again. You know, does that make logical sense? I'll show the value. Yeah, right. And so we see there now. We could plot the vertices. Okay. Now we could make an exercise out of doing this. Like we could plot the other 3 vertices, and then we could use polygons to connect. So some teachers may want to do it this way. To save time, I'll just plot the others quickly. Or if any of you want to rattle them off to me, can anybody? What point is directly above B there? What's it going to be? Again, I can move this around. Just go in the white there.
Is it 9.70, 19.65?
It seems like it. I mean, but you know what? Isn't it okay to be wrong here? Because it's like, it looks like it looks pretty cool, right? Let's see. And then show the value. I would think so. So, are there any geometry teachers in the room here? Like actually high school? I know I said like middle school, like, you know, I'm sure there's middle school here, but are there any high school geometry teachers here? And this is done in middle school too, right? But help me out with geometric transfer, Nicole, or other people. Did you have a question, Nicole, or just raising your hand for answering the question there? Okay, let me see the chat there. Middle school, okay. So in middle school, do you talk about transformations at all? A little bit? Slides, flips, turns, and all that other jazz? A little bit? Yep. So what do we call a slide? What's the technical name of a slide?
Translation.
A translation. Check this out. I could actually take the time to plot all the other corners, which I'll do here. So again, 9.7 over 9.7, back 4.1 for the y, and the z is 19.65. See, that's G. And then what's the last? The last one's the back left corner, isn't it? Which is what? It's going to be 0 for an x because I don't go right or left. Y has got to be down the green 4.1, and then z up in La La Land up there 19.65. Well, like that. And I'll click it and show the value. But see, just an exercise like that alone for kids, I think is very valuable. You know, just having them plot the vertices now. We have them plotted, right? But now, let's actually, if we go to the tools, hit more, we could actually make polygons out of these things, like polygon there. And if I go there, the way the polygon tool works, there's always a hint at the bottom. And if it disappears, you press it again. Touch polygon, it says select all vertices, then first index again. So it's like I'm going to go in a circle. So if I click on A, click on B, then E, then C, and then A. See how A is the first corner I touched? I just made the bottom of that prism. Okay. So again, that's one way to form it. Now I could form the front face. Again, I have to click vertices in consecutive, like circular order, but I close it with the one that I started with. So that polygons tool is still highlighted. I can go A, B. Now I'm going to go up in La La Land there. A, B, F, D, A. See how I'm starting to make it? Now I'm gonna hit that move arrow, and I can actually look at it by spinning it around. So I'm saying I'm starting to build it now. your students can do the same, right? My recommendation for teachers is, given that it's a curriculum crazy year, you know, it's like less is more. Again, when we're teaching students how to plot points in 2D, you know, if they could plot points in 3D, I think 2D is a joke, right? We're not used to the z-axis because we don't really work with it, the z-coordinate. But life is 3D, and so I could always, if you want to ever see it, I love this tool right here. There's so much to show you that I don't want to overwhelm you, but I have to show it anyway. The view in front of tool, it's under, after basic, it's under edit. Let's see the eye right there. If I just click on that, I can click on that gray plane. See how that's what it looks like from this perspective here. But if I want to, but I can hit view in front of and look at it. What does it look like straight on dead like that? Oh, it looks like that, right? It's pretty freaking cool what you can do with it. Now, I actually want to show you another thing you could do here. We're gonna get there, but we could also translate by a vector as well. So again, could we use polygons to plot the other 5 or 6 faces? Yes, we could, and we could save it and we could do it. But let me actually do this because I know it's 3:30. We haven't done AI. To save this construction, let's just go to, you go up here and let's save it. And you got to give it a title. AMTNYS 2020 tryout. I'm going to call it something. You call it whatever you want. Okay. Now you hit save. It's about at the bottom. It says saving, save successfully. So now, here's what you can do now. What you want to do is close out that tab. I learned this the hard way. For some reason, you got to close it out to open it, have it see on your phone. What you want to do now is literally go to your phone or tablet. I'm going to project it here on my iPad. Okay, we're gonna go here, and now we're gonna actually go to Safari. Go to a browser on your phone. Okay. Yeah, a second. Safari. All right. And what you want to do is literally you go to geogebra.org on your phone. This is what we're pretending we're on our phone here. Let me get rid of this. It's getting messy. All right. Again, phone on the left, my computer's on the right. But would you please log into GeoGebra on your phone in the browser? And so some of you, those of you that have actually made that account through Google, you have to log in Google on your phone to do that. So I'm going to take the time to sign in right here. Just give me a second. All right. I just have to stop the share because it shows the name and the password there. Well, I'll share just a second. That's why I had you create your account in the beginning. And you want to log in as you on your device. Okay. And once you are logged in on your device, oops, didn't go away, it did. Let me bring it back. All right. So there, I'm logged in. You can see like the picture of your letters up there. But if you once you're on your device, if you go to your profile, which is right here, you will see on your profile the latest one that shows up right there. That's the file we made, right? I called mine AMTNYS 2020 tryout. Okay. And what you want to do, again, very carefully there, what you want to do is don't click on it, but select the 3 dots right there. Click on the 3 dots. Now, once you click on those 3 dots, you want to click open an app. And if you have an iPhone, before you do that, if you have an iPhone, press it and hold it down and choose open in 3D calculator. That'll open it in the app native to your device. Otherwise, it'll open it in Safari online and it's useless. You want to open it in the native app to your device, you iOS people. Android people, it should open it automatically in the app that you just downloaded there. It should. So I'll open in 3D calculator. And that's literally what I just made right here that you can see. Now, I purposely didn't finish it because of time. But basically now here's like the icing on the cake, the grand finale. How well does this model fit? Well, in the lower corner right here, you see a button called AR. If you press it, it actually opens, you turns your camera on, and for iOS people, you will see a square. Okay, if you're on an Android, you'll see like isometric graph paper. But here is the key for working in AR successfully. Teachers have had hard times. If you want to work in AR successfully, you need to do two things. Number one, you need to have plenty of light. If you're in a dark room, it's gonna be fluky. Number two, you want to hold your device parallel to the desktop or that you're on. Hold it parallel, not like, you don't want to hold it like this, right? You want to hold it like, if you can see me, you want to hold it parallel. But if I tap that square, it'll literally put it in front of me. And I'm actually taking my fingers, I'm not touching this thing because it'll move the points, but I'm touching around it. It's almost like you want to take your fingers, literally, if I can hold it this way, you want to kind of hold it, put your fingers like this in a way. It's the best way. I wish I was there in the rooms with you, like having a normal meet. But the cool part is now, what you can do is literally, you could pick this whole thing up. I would drag the gray plane, don't touch the blue stuff, but you can actually superimpose it over the real one. Actually, I'll bring it back on my desk. Watch this to see how well it fits the model. You know, I could look more, actually this might be better, right? If you look at it that way. Sorry for the mess. But, see what I mean? Take a picture. And you know what I mean? I could save that image. You could have kids taking screenshots. They can be recording screencasts. That thing is kind of glued, right? But at any time I could do that. And I could keep working on it, say in here. Now we're just barely beginning to explore what we can do here in GeoGebra 3D. Like totally. And so basically, can you imagine teachers asking your kids to take their devices, especially those middle school and high school teachers where like 90-something% of the population has a device anyway? It's funny, high schools will say, oh, we're not one-to-one, but if like 90-something% of the kids have phones, it's almost like you kind of are, but you're not really, you know? But that's, in a way, an effective way of working with it. Yeah, Stephanie, I totally agree. It's my favorite app. Now, we're going to even have more fun here because we're going to talk transformational geometry now. Now, I could have, just to show you here, for the sake, we're going to build something else with the time that remains. We're going to make a serial bowl. In algebra and geometry teachers, we're going to come together and merge the two into one to see how this really ties them together richly, conceptually. All right, but before we do that, I want to show you, I'm going to go back to that file there. If you ever want to edit this further, never ever click on it directly because you'll get a view only. You get like something that's like a view only that I can't edit, right? This is just kind of a view only, whatever. See how there's no tools, there's nothing to do. What you want to do on the computer to go back and make more, you want to go here and you want to open an app on your computer. And see how that brings me right back to where I was? Give it a second. Now I'm back to Playland there. Okay. So another thing here that's pretty cool is that, again, if you look here, I just want to show you something else. If you hit the vector tool, all right, you can make vectors to translate objects by. And all you got to do is touch initial point and terminal point. I'm going to make a vector B to E because I'm going to translate that rectangle back. And I'm also going to make a vector from B all the way up to F. Because don't I want to translate the floor to the ceiling to make it quickly instead of going polygon, bing, bang, boom, boom. So teachers that are doing transformational geometry, if your kids study translations, here's a great activity to richly engage them and see if they can build it and model it and flop it on, right? Now, so that's, what other vector do I have to do? Do I have to do any more? I got to go there to there. Oh, I probably need a vector from A to B because we never made that other one, right? We got to actually make a, turn it off. We actually have to, I probably should make one other polygon. Again, don't feel obligated like you have to complete this, but like see here, just made another polygon. If all I made is 3 faces, I pretty much have it. So I'm going to make the vectors what I got to translate those by. And all the transformational geometry stuff is under transform. Aren't those very familiar, reflective about, I mean, this one we don't do too often in high school, unfortunately. We do this one we do everywhere. We do dilations, we do line reflections, right? But let's actually translate by vector. How does that work? You select the object and select the vector. So look at this. That one, I select that vector. See how it made it? I turn tool off. Now I got to take the floor and translate it up like that vector VF. So I hit translate by vector. Again, translate by vector. Hit that translate tool. What do I want to translate? I want to translate that bottom floor. Boom. And I touch the vector I want to move it by. It's this one here. See how I just put it right up there? Turn the tool off. I could turn it. Last but not least, I want to translate this side by that vector AB. Right there. So I translate that one. Touch the vector. I think it just made it. I think it closed it. And now I can go File, Save again. If I give it the same name, it overwrites the old file. If I title it AMTNYS Tryout 2, it'll make a brand new file like a save as. Okay? So that's kind of how you do that there. And if you want, this construction that I just made, if you want to open it right here, I will actually give you the link to this. I see a chat. Give me a second there. If you want to open that on your phone at a later time, or if you just copy that, open it in your browser, it'll open up a new tab. You can actually save it. You can actually go File, Save, and you can make your own copy of it and open it on your phone later, and you can see what it really looks like if you want. Okay. Let's see. I cannot find the AR. My phone closed due to an error. All right. Yeah. In the everything you need is right here in that Google to address the comment that's there. Everything is pretty much in the slides. All right, I'll give you the link again, right there. If you bookmark that, save it for later. Everything, all the resources you need to be found in that 3-slided thing. All right, Google slide thing. All right, so now I want to show you algebra teachers, pre-algebra teachers, and geometry teachers, because we all do. Again, don't we talk about slope? Oh, I think I froze there. Hang on. Let me just stop. Give me a second. I think my computer's on overload here. Let me stop sharing this for a second, because I wirelessly do the iPad to there, and it kind of takes the bandwidth. Let me kill that. All right. Now, our next task, we're going to make this. It's a cereal bowl, right? To build this here, but just to get us a little bit started. All right. I want to see if this makes sense. Now, you can unmute your mics and talk to me. It's like, well, how could we possibly make this in the 3D calculator with, this is just like our first time in there. And I know I'm pushing it just a little bit, but once you see it, it'll make sense. But we love having the origin be a great place to plot a point, right? Why do students love the origin so much? Why do teachers love it so much? What's so nice about the origin?
It's got 0 in it.
Right, and the number of times we can maximize the use of 0 as a coordinate makes our lives easier, doesn't it? So where would you choose to put 0, 0, 0 in this bowl, you think? You can even ask your kids this. There's no right or wrong, but where would you want to put 0, 0, 0, you think, to make this?
In
The center bottom.
I love your thinking. Let's put it right there, okay? And where should one of the axes be, you think? Where should we put an axis, you think?
Straight up through the opening.
Well, so is it okay if we make the x-axis or the z-axis so we could have the x-axis coming out like this, right? Let's see. So I love how you think, and we're going to actually do that right now. So let me share my screen. So if you why don't you go to a blank geogebra.org/3D. In fact, here's the cereal bowl right here. But I have a picture of it that I'll bring up. There. Check this out. Algebra 1 teachers. I apologize for my poor artistry here, But would you expect your students to be able to know what the coordinates of this point is and that point is right there? If they saw this diagram, would you expect your kids to be able to plot those 2 points? Or to know what the coordinates are? Heck yeah, we better, right? Would you expect them also to be able to write the equation of the line that goes through those 2 points? Yes, you do. And you know what? In GeoGebra, if we spin that line about the x-axis, we make what we call a surface of revolution, right? So we could totally do this. And even if you're not teaching linear equations, you know what? If all you want to do is point plotting and you're talking about cross sections and surface of revolution, you could just plot the 2 points, make the segment, and spin the segment 360 degrees. It's so easy to do in GeoGebra 3D. It's so easy. You're going to be blown away by how easy it is. I'm going to show you here. So let's go back here. Well, I got to clean this up a little bit. I want to leave room for that. All right. Whoops. I'll keep that smaller there. There we go. Perfect. So now back to GeoGebra's home, 3D calculator. All right. So we know that we have the points, right? If I do this, if I'm thinking correctly here, we know we need the point 0. Well, I'm going to plot the point 0, 0. Not that we need it, but I'll plot it anyway. We have the point, what's that, 7 point. By the way, if you keep it in 2D, it puts it on the XY plane anyway. See what I'm saying? Red is X, Y is green. Let me just go ahead and show the label, the value. If you ever want to make it bigger, you just go to settings gear, settings, you just can make it like ginormous. I'll make it 28, right? So B, oh, that's 7.100. What's this point right here? Anybody? What's that ordered pair right there?
0, 4.5.
Bingo. And what's this point going to be up here?
7.1.
7.1. Whoa, hang on, what happened there? 7.1. It's actually further up the y-axis, I think. So again, 7.1 out. What was that? 7 point. I guess this is what 7.1. The radius and the height are equal here. No, it look like it. But would it be
0, 0, 7.1?
Not quite. That's okay. If it's your first time in 3D, it's no problem because we're actually, again, Z is going up. Again, it's a different way of thinking. If we're not used to 3D, but let's just look at it this way. All we want to do is stick here. This is 7.10. This point here is 4.5. Again, the Z is 0 here.
So 7.1, 7.1 then.
Very good. Excellent. Yes. Yep. And I'll put a 0 there. So it's almost like we're forming the ball, right? And I'll go E. I'll show the value. You see, your kids aren't going to become masters this on the first day. I mean, some of them will kind of take off with it, but it's almost like what I want to do is I'm going to go to more. All I need is a segment, right? Segment has 2 endpoints, so touch and boom, there you go. And it's almost like now what I got to do is I got to take that's what we call a cross section, right? Don't our students struggle with seeing cross sections all the time? I mean, like, well, we spin it about the line and we can be, oh yeah, but you know, that's called the cross section. So now, again, I have to turn that segment tool off and touch the arrow so I can move stuff around, right? Now, what I want to do is that the goal is to spin this thing to make the ball. What am I going to spin it around? What's the axis of rotation here? What am I going to, go ahead.
X-axis.
Very good. So here's how to do it. You don't need to be a tech expert to do this. It's easy. What we're going to do is I'm going to type in n equals 0 DEG. Go ahead and do the same. And if you work in Desmos and mess with sliders in your calculator, it's the same thing here. N equals 0 DEG and hit enter. It makes a slider.
Oh, cool.
Yeah. And now, you know what? My favorite command in all of it, you just type the word surface. Ignore all the crap that comes up, open parentheses. Can someone tell me the name of the segment? What the heck is the name of the segment we're rotating? What did GeoGebra name it?
CE.
No, what's the name? Look to the very far left. What's the name of the
Oh.
object?
Oh, lowercase f.
Yep. Anytime you put something in GeoGebra, it always gives it a name. I want to take segment F and I want to spin it n degrees about the x-axis. Just type, that's what you want to type there. Take the object, rotate it n degrees about the x-axis. Now, all the stuff that pops up below, you can ignore. That's all the parametric, high-level calc stuff. We don't need that. You just, if you tell GeoGebra what you want it to do, it'll do it. You just got to tell it correctly. Okay? But look at this. Enter. And then spit. Oh my goodness. Would you look at that? What? Yeah. Right? Now use your mouse to zoom out. What do you think? Not bad, huh? Now,
All the cereal's gonna fall on the floor.
oh, so should we make, you want to make, should we make a circle that's filled to cover that? We probably should, shouldn't we? Now, time's not going to allow for this because we only have 8 minutes, but if you email me, I'll show you how to do that. You just got to keep it in that, you just got to keep the plane there. But right here, let's see. It's totally fun. Yeah, and it's totally easy to do. Now we're going to open this on our phone. But algebra teachers, you see, you can make this an activity in linear equations and piecewise functions. Because instead of taking the segment here, can anybody give me what's the equation of that line going to be? Through 0, 4.5, and 7.1, 7.1. Isn't it just, isn't it really just y equals, what? Let's call it g of x, or a function, equals, what's the slope? Do we need the slope? What's the slope of this thing? Rise over run, right? 7.1, watch this, fraction bar. 7.1 minus 4, isn't that the rise? Y minus y, right? Over that minus that. Plus, what's the y-intercept? What's the y-intercept to this function here?
4.5.
Oh, moved it up, yeah. Oh, but wait, we need a domain restriction, don't we? We need to chop off those ends. Now, honestly, what high school or middle school students truly give a crap about domain restrictions? They don't, right? But the thing is, if we make it an art form now, this kind of forces them to think, oh, you got to restrict the domain to what? X values between what and what?
0 and 7.1.
0, less than, you could do less than equal. If you type in less than and then the equal sign, it already puts that line in there. Just type in this less than next to the M, equals X less than equal 7.1. See how it actually chopped off both parts of that line? And now you see how I made a surface by rotating the segment, but I'm going to hide the segment now, and I'm going to hide the blue surface. You know, in Desmos, the bubbles turn things on and off. Well, guess what? If I do surface, take function g, n x-axis, right? I can now do the same thing, but this time I actually made it. I made an application of linear equations in Algebra 1 instead of just a plain segment for like the 5th grade kids. I now made it an algebra, pre-algebra, Algebra 1 kind of a thing for the middle school 8th grade kids, if that makes sense, or wherever it falls in the curriculum there. Your students can build. They can totally do it. Our job is to give them the opportunity to do so. So what I'm going to do now, we're going to put this to the test. I could take this. You can have your kids go to the object, go to settings, color, right? We'll make it, or maybe a bright kind of yellow or something like that. I don't know if that looks okay. But what we'll do is I'm going to save it, and I'll give you the link to my construction here. So File, Save. I'm going to call it Spatial, and then Save. Right? I'll drop it to you in the chat here. In case you want to open this up. Whoops, wrong one. I got to copy the URL first. I'll paste it in the chat. Now take that. If you can get it from your computer to your phone, maybe you got to email it to yourself or something like that so you can look at it in AI yourself. I might be able to make it, or actually if you want to just type that in, if you type that in on your device, how can I get this to your phone quickly because you're not watching Zoom on your phone? Like there. But basically, I'll go ahead and save the trouble, but to look at this now, let me open this up one more time. Oops. Close out the app. It's coming. It's coming. There we go. Again, I'll just keep it over here. There. So now let's check it out. I'm going to go to GeoGebra here. I'm going to refresh the page. Let's go back a notch. See, anytime you save it, it goes to your profile. I have AMTNYS right there. It's right there. So now I'm going to do that. Press open in app and hold it. Open in 3D calculator. And there's my bowl. Now, I want to get rid of that gray plane because it's kind of ugly. To get rid of that, you want to go up here to the settings. You can hide it and just hide where it says show plane. I can show the axis. I think it might be meaningful here. But now put it in AR. Remember, parallel to the floor with the parallel to the surface with plenty of light. There it is. Look at that thing. It's almost like I could jump in it. You know? I can go in it. What? You know, I mean, it's pretty cool. But right here, now here is the ultimate test. You have your kids. They can actually hit the record button and send you a screen recording of this. Your kids know how to record on their phones. Almost every one of them does. So don't say you can't do it. But watch this now. Ready? Take that, see how well it fits. There you go. And that's the power of GeoGebra 3D calculator right there. But think of the possibilities you can do. What if I ask my kids to actually hold the bowl this way? 0, 0, 0 is down here. The z-axis is going to stick up and go right to the ceiling. But I would have to know that bottom radius. And couldn't I make a segment that goes from here to here and then spin it about the z-axis? Because doesn't the z-axis spinning up and down? Did you know? I mean, like, I know I'm almost out of time here. I got 2 minutes, but because the cool thing is you can actually, what I didn't get to show you enough of here is that you can actually do this on your phone AR. If you want to make a cube, say, you could, or plot a point, you can do it right. Oops, sorry, crash there. Normally that doesn't happen. But you can actually literally do that right in here. So with AR, you have a blank slate there, and you could actually go ahead to plot a cube, right? Or plot a point, or to make a cube. I can actually plot it in my space. I can actually try to make this again, or just kind of hold it that way. I can go here, or I try to make the polygon, right? Or go to 6. The point is, there's my cube, and I can actually move it around and see, and jump into it and do whatever. Again, the possibilities are endless with what you could do here in AR. But again, if most of your students have their own devices, they can download this app totally free and get a lot out of it. The last thing I want to show you here, and I'll do this again because I know we're out of time, is in this presentation, which I'll give the link to yet one more time again in the chat. Again, please save it in a good place where you can access it later if this really interests you. You can. There's a lot of pre-made activities that you can open in AR right off the spot, and they are found on the second page here for geometry, pre-calc, and calc, and also a step-by-step course right here. I'll go to the URL there. If you want to start doing this with your students, like there's a part 1, part 2. Actually, part 1 is kind of what we just did here in this session, right? See if we could build it. See how we kind of color-coded it. There's a demo and, you know, kind of a model here. So again, taking baby steps. You could teach yourself this and work with it, but 3D, the cat kits and everything, but is all there. And then last but not least, if you want some more ideas for teaching and learning, I post a few every week. If you quickly hold up your phone to the screen, you can take a picture of that. In that URL there. I post on social media a couple times a week, just some ideas. I learn so much on Twitter from people, and Instagram and Facebook, whatever. But again, I learn more on Twitter from scrolling 2 minutes a day from a lot of other experts and meeting than I do going to like a conference that my district would pay hundreds of dollars for, you know? So if you take a picture of that, you have some links to some other stuff there. I love augmented reality. I love empowering teachers to engage your students to do this kind of very thing. I love working with students, but if your district's looking for some special development, I mean, I'm totally available virtually. So again, I hope you have a wonderful afternoon. If you have another question, I'll answer that. Feel free to send me an email. It's tim@geogebra.org. Okay. Yeah. Okay. So if you need to go ahead, sign off, sign off.